Hello, GMDS. Let's see, what are we listening to? Zelda playlist? Zelda playlist. Well, hello everybody. Oh no, what happened? Did I get raided by Toggle? Oh shit. Well, thank you for the raid, Toggle. Sorry, I wasn't here. I was getting the stream started. Oh shit. Hello everybody. God damn it. So, hello everybody. What we are doing today is fuzz testing. This is going to be an entire stream entirely dedicated to fuzz testing, start to finish. What's happening is that I'm working on a JSON alternative, which this is the website that you're looking at. That's Ziggy. I call it Ziggy. The website is ziggylang.io. You see it written here, here. And yeah, what can I say about it? I don't know. It's a JSON alternative, has more syntax. It's less bad in some ways. But, you know, of course, it's a niche thing. So that's what it is. But I'm working on it. And is it another type of Zon? I mean, if you consider Zon a data serialization language, then in that sense, yes. The difference, though, is that Zon is a data format that is, understood by the Zig compiler itself. It comes with the Zig standard library. So it's a data serialization format that is deeply embedded in Zig, and it is also not weird in the sense that it is a subset of literal notations in Zig. So it's meant to be not particularly crazy. With Ziggy, I'm trying. It's a bit of a more ambitious idea with some ideas in it that. For example, I had some features that I had decided to remove in previous iterations because they didn't pan out. Like I tried to make them work in the, with the other features, and they just were not a good fit. So the difference is that Zon is less weird, kinda more of a standard. This is more experimental. Is this related to Zig? It's related to Zig in two ways. It's related to Zig in the sense that it is implemented in Zig, and it is related to Zig in the sense that the notation that I'm using is inspired by Zig's notation. So it looks like Zig's notation mostly, but it's not a one-to-one. So yeah, I don't know. In any way, what are we doing today? Today we're doing mainly this. So yesterday I fuzzed the parser for the document format. So this is what Ziggy looks like. But Ziggy also comes with schemas, and I have a schema language, and the schema language is a different language. It, on one hand, it is annoying because you have to learn two languages. You don't do things the same way, but at the same time, this schema language is very much inspired by Zig, like very, very much inspired by Zig. It's like it's 98% the same. So if you're programming Zig, you don't even have to think about it much, pretty much at all. And also, it's because I really hate how JSON schema does it offer completions like JSON schemas? Well, yes. More precisely, it's not the schema language that does that by itself. It's the language server, right? So yes, I do have a language server. Ziggy, there's a Ziggy CLI tool that has auto formatting, schema checking, and a language server. It should also have format conversion and document querying. Think like JQ. But query and convert have not been implemented yet. Convert has something implemented, but I think it regressed, so it's still work in progress. But auto formatting, full-fledged. Schema checking is, it doesn't do all. I haven't implemented 100% of the checks that I want to implement, but I think let's say that if you're writing a normal document and you have a normal schema, then it will find trivial things that don't match. But I know that I have some to-dos left here. I just don't remember what they are because I have paused this project for a while and moved on to something else, and I'm returning to it now. So and the LSP, that one is fully fledged. Like, or rather, it is limited by the fact that, for example, the LSP will do schema checking, and the ability of the LSP to do schema checking is limited by the schema checking implementation. But other than that, it is a full-fledged full-fledged language server. So yes, it will provide you with auto-completion. And that part I'm serious about. If you want to get an idea in general, while this, I would consider this project to be alpha level, between alpha and beta maybe. But when it comes to language servers, I'm in a pretty good spot. I have this other LSP that I made a while ago. It's called Super HTML, and it's a language server, auto formatter and whatnot for HTML. And it is really, really good and really, really strict. So I actually would encourage you to try this out if you are dealing with simple HTML. If you're doing templated HTML, you cannot use this tool because this tool will do all the semantic checking that it can of your HTML. When I say semantic, I mean it will look at nesting rules. For example, it will, for example, here, this is trying to put a div inside of a p tag that is not allowed by HTML. This one has a duplicated ID. So it will tell you that you have a duplicated ID value. That's also bad, not allowed. It is also template aware. So it understands that if you have another ID instead of a template tag, that doesn't collide with this guy. But if you put a second, like if you copy paste this line here below inside the template tag, then yes, that will be reported as a duplicate ID value. So it understands all this stuff. If you have templating logic, you know, like mustache, curly braced shit, those things do conditional logic that Super HTML is not aware of and it doesn't understand. So it won't work. But if you're dealing with clean HTML or the output of some templating language, so not the sources, but the output, then Super HTML is going to be great. You can have it also in VS Code. There's a couple of interesting details. You know what? Sorry, I'm gonna do a little bit of marketing for Super HTML. I'm gonna switch back to Ziggin. So the auto formatter has this nice feature where if you put a space between tags and you save, the space tells the auto formatter that you want vertical alignment. And to be clear, semantically in HTML, having a single space or having a bunch of spaces and tabs and a new line, it's the exact same thing. In terms of rendering, what makes semantic difference is not having any white space between two tags or having white space between the tags. That does make a semantic difference. But then once you have a space, whether it's one space, 5 spaces, a new line, bunch of tabs, doesn't matter. And it also works the other way around. So if you then delete this white space and you pull up this part, then the auto formatter will know that you're asking to pull everything up and compact everything. And it also, the same idea works with attributes. If you have a line with attributes and you put a space between the last attribute and the closing diamond bracket, then you're asking for vertical alignment, which looks like this. You cannot configure it, by the way. This is what you get. You get vertical alignment with this style where the first element goes on the same row and the other ones are aligned with it. We use tab for indentation, space for alignment. And then if you don't like this and you want to return, maybe you had a bunch of attributes that essentially made it the right choice to align everything vertically, but then you delete those. So you want to go back to horizontal alignment. Then what you do is that you remove this white space here. You put it back like this, save, and then the auto formatter will pull everything up automatically. And yeah, so there's a VS Code extension if you want. There's also the same extension is also available on the other one, OpenVSX, the one for VS Codium. So you can also get it from there. Yeah, enjoy. So So long story short, and this also has all auto completion and whatnot. So by the way, this is the only language server on the planet that does this. Nobody has ever done this before. If you open VS Code normally, you will not get any HTML diagnostic. If you're using the JetBrains tooling, you will get some diagnostic, but nowhere near this complicated. They have a super simplistic system. Well, not super. They have a simplistic system, and I call it simplistic because it is, by definition, not complex enough to encode all the actual rules of HTML. So they will give you, like, the JetBrains tooling will tell you that you cannot put a div inside of a p tag, but it will not know, for example, that you can put an anchor inside of a button as long as it doesn't have an href attribute. And not only I tell you, I recognize this case correctly, but I even tell you the reasons. So invalid nesting under button. So you see, div is unconditionally invalid nesting under p, but a is invalid nesting under button because there's the href attribute present, and etc. etc. So I have all this stuff. The whole stupid HTML spec is encoded in this tool. Horrible, really horrible to do, but now that it's done, delightful to use. So okay, I'm done with Super HTML. Let's go back to Ziggy. Let's see. Maybe I'll use Ziggy for the config file. Yeah, be aware of one thing. Ziggy is, I think that Ziggy is going to be a delightful experience. It is designed so that if you use it as a config language, then you have a nice schema where you put doc comments, and those will show up in the LSP because it will do autocomplete. Like, for example, if you have a license field, then you can choose between these two options, and as you type them, it will autocomplete them, and it will show the doc saying, the one is a SpeedX identifier, the other one is a URL. So it has all the features that you would expect. Be aware only of one thing. This project is still work in progress. So the key difference between other alternatives is that I'm still fucking around with it. You might encounter bugs, which I'm in the process of fixing also thanks to the fuzzing that I will do this stream. But you need to be aware that you're buying into a unfinished ecosystem. As long as you're fine with this, as long as you accept the fact that occasionally you will hit some limitation, you open an issue, it will take me a while to fix it, then you will have to upgrade and that kind of stuff, then you're gonna probably have a good experience. Otherwise, if you want more stability, if you don't want to have to think about it, stick with Toml, maybe switch to Zon if you, I don't know, want something less standard but not as insane as Ziggy. That might be the better choice. So just be aware of this. So what else is there? Can you help me with asset streaming with Ziggy? If you mean whether there is a streamed version, like support for streaming documents in, not really. What you can do is have every single line of your thing be a full Ziggy document, right? Just like what's it called, JSON line. So you can do that. I have not considered streaming a single document a particularly interesting use case. Because you can do the lines thing, but I don't know. If you open an issue, I'm happy to maybe discuss it. But really, I'm not sure. Let's see. All of your 4 major projects look really like a lot of work. Yeah. They are. Yeah, I don't know. I wonder how you deal with migrations on all. You mean migrating Zig versions when I update Zig version? I don't know. It's just what do you call it? I don't know. Greet. Like, you just do it. You just don't think about the work ahead of you, and you just sit down and you do it. And at some point you just power through it, and at some point you will be done. That has been the policy so far. Okay, so yesterday, what happened? yesterday I fuzzed Ziggy a lot, and we got to the point where we got zero. Actually, I don't remember if we got to the point where we got 0 bugs from the fuzzer. I think we got there at the end of the stream. Then I left the fuzzer running a while more. It found one more crash. I fixed it, and after that, there was no more. There were no more crashes, I think. So I left it run for a long time, and it ended up not finding anything. So for now, we are satisfied with the document AST, and we are satisfied with document formatter. Then earlier today, I launched this guy on. Or was it yesterday night? I think it was yesterday night. I launched this guy on the schema parser. And it turns out that the schema parser has crashes in it. Who would have thought? So we're now on the adventure of fixing crashes in the schema parser. And I don't know, maybe if we are lucky, some of these crashes are not just programming errors. Maybe we hit a to-do, which might give us a clue as to where I left off implementing schema checking, because I know that I have not completed that thing, but I don't remember at all what it is that I have implemented and what it is that is missing. I just have I have a shadow of a memory in my head. So yeah, let's do this, because the schemas also need to be parsed. Schemas also need to be formatted. And so here I have the AST test, which is what we did yesterday, and we essentially have consumed all the bugs that we found. And now, sorry, this is test AST. I'm dumb. This is test AST, and now I'm running test schema AST. And for now, we are not even testing the auto formatter. This is false end, so I'm turning this part off. We are just creating an AST and de-initting it. That's all we're doing, and we're already crashing there. So let's go fix this stuff. This is the first crash that we found. So there's in the tokenizer, in the schema tokenizer, we are indexing past the end of an array. We're doing an index out of bounds. So I don't know. Let's go figure out why this is happening. So to do this, I'm gonna do this, and here I'm gonna go into schema tokenizer. Let's just quickly scroll through this so I remember vaguely. Yeah. Okay. Okay, so line 266. There we go. Okay, so what are we doing? Optional. So we found an optional. Okay, so we have a token that represents an optional variant of one of the sigil types. So you have the sigils that we have in the schema language are this one. So square brackets, like in Zig, represent slices. And this instead represents a dictionary. It represents a key value mapping. This is a sigil that doesn't exist in Zig because Zig does not have a language level schema type. So it's something that I made up for Ziggy, and personally I love it. I think this sigil is really cool, and I'm happy that I came up with it. It's not genius, by the way. It's essentially a dictionary in Ziggy is the JSON syntax. Maybe I should explain briefly what this is. So the idea is this: in Ziggy, you have dictionaries and structs. A struct, they are both key value containers. So in terms of maybe not semantics, but in terms of mechanics, they are essentially the same thing. But a struct means that the fields are controlled by a schema, and each field has a specific semantic meaning for the application that is supposed to consume this file format, this document. And they might have rules about which one has to be there, which one, like this struct has do send the roles extra, and that's it, for example. A dictionary instead is still a key value pair, but the idea is that keys are not controlled by the application. Keys are not part of a schema. They are essentially free form for you, the user, to do what you want with them. So, for example, if you have a thing where here this message has a payload, the payload is of type command, and the command needs to have important information as to what command it is and who is sending it and what permissions do they have. But then there might be extra metadata that you keep there, only for logging purposes, for example. So extra information that might be useful for the user, but that does not have semantic meaning for the application, because roles are something that, for example, in this example, roles might be something that decide whether the command is allowed to be sent, to be processed or not. But what's in extra shouldn't have this, shouldn't participate in that decision-making process. So you put in here whatever you want. And in this case, in this example, I said, well, let's say that we are logging which browser is being used and which OS it is being sent from, for example. So here's another funny thing that comes from that. This syntax here is JSON. The Ziggy is a JSON superset. So you should, this is there's a star because of the implementation, some things that I still have to work out. But the idea is that you can take any JSON document and load it as a Ziggy document, and that will be loaded as a Ziggy dictionary. So JSON is a Ziggy dictionary. And then the idea is that then you can upgrade your JSON document into a Ziggy document by turning dictionaries into more expressive types, into structs, essentially, if where it makes sense to do that. There's even features in the LSP that support this use case. Actually, let's see if this still works, or if I borked it. Actually, I'm gonna copy this. Let's see if this works. I haven't tested these in a while. So I'm gonna call it foo.ziggy. And I'm gonna paste this JSON in here. I think the LSP is not running. Am I getting an error from no, the auto formatter? So I think this should be fine. Okay, I don't know if it's gonna work because I'm a bit surprised that the auto formatter should eat these spaces. So I'm wondering if my this is wrong. Change file type. Oh no, it does have. Okay, so it is Ziggy, but it has the Zig logo. Okay. Okay, that sounds good. Okay, so there's a feature which I'm starting to wonder whether there's something. I'm gonna try to demo it anyway. But structs have a dot in front of their name, and so when you save, the auto formatter should automatically change the style of these fields, but it's not doing it because something is broken. Okay, so time to fix this as well. Let's do this crash, and then let's see why the auto formatter doesn't want to work. I might have broken something in the LSP. I don't know. So here we're going out of bounds. Why are we going out of bounds? Let's take a look at the example. So this is the use case. I think I get what's going on. We are at a curly brace, but we are at the end of the string. And here we are trying to go further, but we don't realize that we are already past the end of the string. So what we have to do is t.idx must be lower than tidx plus 3 must be lower or equal t.len, and then we actually do it. And this should get us into the invalid token state. So here we build, we rerun the test, and in theory, okay, we hit compile error. What happened? Oh, there is no t.len. I'm wrong. I'm dumb. It's source.len. Let me reset this up in the meantime. Source.len. Okay. Okay. Ignore the failed command stuff. This is just complaining because these command printed something out to standard error. I think that technically I could do this. Oh well. Okay. And now we don't crash anymore. Next test also doesn't crash anymore. Well, I think with this change we already fixed a bunch of crashes. Okay. Can it be equal when you leave the bounds? But it can be equal because we use it as the second part. We use it as the end of the slicing, and this is still a +1 thing. This is still a I don't know what to call it, but in any case, this can be len. Essentially, when you have something, when you have source, if you do 0 to the thing.len, that is the same as source. Yeah, it's not inclusive. Okay, so we fixed a bunch of fuzzing bugs. Let's fuzz some. Let's restart the fuzzing process. I reset the entire thing because there were more test cases before, but I tested a few. There were like 40. I didn't want to have to go through all 40 of them, so I just nuked the directory and I restarted the fuzzer, and we'll see if now we can find crashes. I remember fuzzing these parser in the past. So this has already been fuzzed. Then it was modified a bit. I think that in the past, the major difference between now and the past is that in the past, in the past, I had for types, instead of doing this is a map of numbers, I would do this. I think what syntax was I using? Oh, it was horrible. I was doing map of int, and then for now I do this is a slice of int, and previously it was int. It was wrapping. So if you add a map of slices of int, it would be a map of this. While now this becomes this. This is better than this. I like this. Like, I like the notation of putting in square brackets a type if it's a slice of this type, but it doesn't work well for maps. It makes you go full Golang when you do that, and that is not nice. So I decided instead to say, okay, I'll give up on this. Even though I like this, I'll give that up. And I'll go with this, which I like less. But at least this is Zig-like. This is much more Zig-style syntax than this. And that also gave me the opportunity of saying, okay, so now I have to come up with a sigil for dictionaries, and so I came up with this, which is, I mean, I don't know, sorry, it's such a good sigil. I love it. So this was the main change that I made. So the fact that we found a crash that relates to this change, but then we don't find many more crashes after that, that does check out. Keep in mind, we are only fuzzing the parser. So we're doing a very targeted fuzzing where we're just fuzzing this AST creation. But since I am not finding anything, I think that we might as well, at this point we might start opening the door to the rest of the stuff. Hmm. Yeah. You know what? Uh, to be clear, for people watching, stopping the fuzzer now, like the fact that we haven't found anything for a while, it is absolutely not guaranteed that we are bug free. First of all, obviously, there might be bugs. Also, wait, did Bork crash? No, Bork did not crash. Oh, I think it's the YouTube stuff that crashed in the meantime. I saw some glitches here. Oh well. So I was saying, obviously there might be bugs that we are just not encoding to a assert tripping to a crash. So the fuzzer obviously won't be able to find those, and that we can take it for granted. That's basic. But the fact that it has not found crashes yet does not mean that there are no crashes that it could trigger. Because you know this fuzzer is kind of smart at exploring the space, but it's not genius. So there might be something that it's missing. So with that being said, um, it is also true that in my experience, oftentimes, especially for stuff like parsers, where I would say that the problem is parsers, tokenizers, and especially, and then also parsers, it tends to be more that the conceptually speaking, it's like the problem space is wide, but it's not too deep. So the fact that the fuzzer hasn't found my point is that when there's bugs, usually the fuzzer finds them fairly quickly. Then if after a while it does not find anything, then maybe there is 1-2 more bugs, but it's nothing major. So you can stop here, and chances are that if you give this software to your users, they will not have a bad experience. They will not, the moment that they start using it, they will immediately hit a crash. So um, in terms of tooling like formatters, etc., this is good enough for usability. Maybe not for correctness, for guarantee that what you're giving out is free of defects. But in terms of like avoiding the embarrassing thing where you say, oh, you know what, I just made my parser for my new language, then you give it out, and then as the person is typing their first line, boom, it crashes hard, like the LSP crashes hard. So that is the part that you want to avoid. And fuzzing for like 5 minutes or something, enough to guarantee that. Certainly true for stuff like data serialization languages. Programming languages and whatnot might be, maybe the threshold for that level of quality is more than 5 minutes. I don't know. Also, it depends on how many iterations you can do per second, right? But let me put it this way. If you've done 20 million executions with AFL, with a well-instrumented executable, then you're good. Okay, so with this, let's expand our search a little bit. So turn this on. And then let's only do round one. So here we're going to do if true, return. So we're not doing the full round trip, but we are formatting once and expecting only also we don't need to do fix-ups because there is no concept of fix-ups in the schema language. So we expect one round of formatting to be producing the same document with just the white space that changes. Everything that is not white space should be the same. Which color scheme are you using? I'm using, I believe, IU Mirage. In any case, it's an IU variant. Okay, so let's rebuild the fuzzing executable. Fix completion things. What is going on here? Schema ST render. What's your problem? No function name render in schema ST. Oh shit, how did I call this thing? Really? Don't tell me it has format. Oh, this is the parser. Node. Okay. Never mind. So then it is below the parser, I guess, maybe. Resolve Ziggy offset. Oh, I think this is the parser. While true. Oh no, this is validation. Okay, validate. Print docs. Oh yeah, I called it FMT. So you call FMT to get a formatter. So there is no, but wait, what does the formatter call? Oh no, it doesn't call shit. It implements it. Okay, so fine. Let's turn this into an FMT call. So this means that we're gonna do r1 buff.writer print as schema ast fmt. What do you pass to fmt? Source. Understandable. So that is the replacement. Okay, are we happy now? We are. I am surprised to not find crashes. So if we hit 20 million iterations and we do not find a single crash, I will manually introduce a failure in the rendering code and I will test how long it takes us to find um that thing. Just to double check, again, I have fuzzed this project in the past, so it is not unthinkable that there just are not obvious bugs in this code. Okay, maybe it will take a while to get to 20 million. I should set up the multi-core fuzzing stuff. I've never bothered. But probably I also I don't understand why they make it so complicated to do multi-core fuzzing. I get that there are like issues with multi-core fuzzing. Like it's not how can I say there, let's say there are trade-offs involved, but man, they if because the thing is, I have like what 8, 10 cores. I could go 10 times faster just because I could use my other cores while this is running on a single core. Let's stop at 10 million, not 20. And by the way, for clarity, the reason why why this is taking longer is because we're doing strictly more work. We're doing everything that we were doing before, plus also the rendering. Yeah, fuck it. Okay, let's stop early. This is fine. Sure. Ignore white space. Also, the two upper stuff is not important. That's a leftover from. I copied this code from the HTML parsing code, so that's fine. Let's introduce a bug, and let's see if we can find it. Uh, do. While I the next, write all talk. Um, nodes, blah blah blah, exercise, blah blah blah. Space TRN. Oh wait, that is what we're tokenizing on. Okay, which makes sense. I'm trying to find a thing that is not immediately obvious and common, but let's do it this way. If index equals 10 and talk 0 equals A, W write all X. So in theory, this condition should trip the equal checker. Let's see. And this condition is kind of cursed. Like I'm trying to put in a condition that is not trivially executed, kinda almost unconditionally as soon as you get into this case. So I wanted it to be kind of a non-obvious thing. Okay, what's the problem? Oh yeah, I need to give it a dub. Fair. God damn it, man. What have I done wrong? IDX usize equals 0 plus 1. Okay, what is your problem? Error union. Oh shit. Okay. Actually, you know what? Let me remove what's in out. Okay, let's see if we can get in there. If after 5 million iterations it has not found it, then we can try to simplify the condition and see if we can find it. Yeah, sorry, YouTube is bored. I can try restarting. You know what? I'll restart Bork. There you go. Oh, here's why it borked. It borked because Google kicked us out. I fucking hate this. Um, I'm finished back in 5 minutes back in the stream, but could you use STD mem starts with instead of checking the bounds and all that? Yes, you're right. I could. You're totally right. I could. That is a good point. I'm gonna go change that line. So in the meantime, it seems that we have not been able to trigger this crash. Let's see if we can simplify the condition. Oh shit! I closed Borg, of course. Uh, let's simplify this. Just token has to start with A. Wait, is it possible that it's impossible for a token to start with A? No, it should not be impossible. Let's see how this goes. Also, in the meantime, I'll go into the tokenizer and I'll replace this with what you said. That is a good point because we can totally do that. Thank you. Very good suggestion. Oh, we have failed our unit testing with that change. Okay, because we have a field. Oh, here what happened. Any became X any. Okay, cool. Pause. Yeah. Now it finds crashes very quick. We can probably have a middle ground thing where the condition instead of being um, x equals 10, we can say x greater than 3. Let's see if that helps. I suspect that that part was the hardest part. Yeah, check this. Oh, wait. Move out and then rebuild everything. I think it's the numbering condition that is the one that essentially this condition is requiring it's forcing a longer valid input, and for the fuzzer obviously it is harder to get into valid inputs that are longer. You can imagine, right? You can it is much more likely that the fuzzer is able to find a valid input if, let's say, five character long inputs can be valid. It is easier for the fuzzer to find a valid 5 character input than a valid 200 character input. Oh yeah, I should also not slice. Yeah, good point. Um, Wait, not all of it. Here we go. Yeah. There we go. We're finding crashes. Uh, yeah. Okay. The crashes that we're finding is because of my wrong slicing. Okay. Let's reset. Okay, let's do 5 million. If 5 million can't find it, you know what? I mean, it's fine. What we wanted to test is that it's fun to play, to fuck around with the fuzzer, but we already tested that this stuff is being tested correctly and it is genuinely not able to find any obvious crash. So I'm gonna undo the changes here and do some actual work. So what is actual work in this context? We need to increase the test coverage. So we are not testing the whole library. We are testing it bit by bit. So now we want to uh, increase coverage. So there are more parts of the library that we're not testing yet. So we're gonna want to focus on those. Yeah, okay. It doesn't seem to really be able to find that crash right away. That's fine. We tested what we needed to test. So let me undo these silly changes. Okay, back to normality. Okay, what do we test next? So there are two things that we're not testing, like two big things that we're not testing. Um, one is uh, the um, the type-driven deserializer, because we have been testing the parser that takes a Ziggy string and turns that into an AST. But we have another implementation that takes in a list of tokens and turns in and immediately deserializes those into a Zig type. That guy is harder to test for because we cannot have the fuzzer drive the schema creation. The fuzzer can only drive the schema creation. The fuzzer cannot drive the decision making for what the Zig type should look like. So that part we cannot fuzz as easily. Like technically we could, it's just janky and slow. So let's not do that. What I'm gonna do is I'm gonna create a list of types, and we're gonna have the serializer try to deserialize in all of these types the Ziggy documents that have been randomly generated by the fuzzer. And the hope is that the variety of types that I choose to deserialize the document into is varied, is different enough that will allow us to explore the deserializer code enough. Unfortunately, it would be better if we could have both ends of this process be driven by the fuzzer. Yeah, but we can't realistically. So we'll have to make do. Okay, so what does that look like? So that means that we are done testing the schema EST, and now we need to test something else. So we need to test the serializer. By the way, there's also a serializer from a Zig type to a Ziggy document. But that is also problematic. No, actually, wait a second. That is delightful. Oh my god, look at that is delightful. We can test both at the same time. What we do is fuzzer creates a Ziggy document. Deserializer tries to map it to a Zig document, to a Zig type. And there's a list of those, most of which should fail. Hopefully one succeeds. They also all can fail because the input might not match any of those shapes. But if it does match one of those shapes, then we do the round trip. We serialize that value back to a Ziggy document, and we test that they are the same modulo white space. Almost. It cannot be the same modulo white space. So the variance there can be white space, presence or absence of comments, and trailing commas. These are the three things that could be different. So in a sense, I guess we kind of would like to run both the input and the output through the auto formatter, but also strip comments. Or we could test that the list of tokens. Oh, you know what? We could test that the list of tokens is the same. And we run the tokenizer in a mode that strips comment, that ignores comments. And then we ignore extra commas. Yeah, something along those lines. Okay, I guess we can do it. We can work on ideas later. So give me a second. I'll be right back, and then I'm gonna do this work. Okay, let's fuzz. So, deserializer, same deal as before, GPA source, make the function. Oh, you know what? Okay, that's deserializer. Test deserializer, we need a list of types. Where do I put those? You know what? I feel like this function should be moved at the end. And I'm going to put the list of types above it, but outside of it. Actually, does my no, let's put it inside. So const types is going to be it doesn't matter the type because we can do it this way. Actually, the ampersand is also not necessary. Okay, what are these types going to be? So we're gonna try to slice something to deserialize something as a F32, F64, U32, I32. I think this is enough for numbers. Then slice. What else? Actually, does the deserializer support row types? You know what? We're gonna find out soon. I don't remember if my deserializer supports passing in a non-struct top level element. It might. You know what? We can do a one-to-one mapping essentially. There you go. That's fine. And we made the rest structs. So what do we do with that? Um Hello, hello. Is that Breath of the Wild music? Yeah. I have a Zelda playlist in the background. Hello, Mick. What do we do next? I guess we do a few structs. Struct that has A, B. Oh, also we should have bool. Bool. Oh, we're missing optionals. Let's just do optional of 32. I think we can do optional bool, I guess, but maybe we should do optional variants of these guys. Wait, on the outside? No, on the outside doesn't make sense. It's on the inside that I think it's more delicious. Can try this also. Hmm. Okay. I really like Zig, but I struggle understanding how to do basic IO from STD in to STD out after the 0.15 update. The 0.15 update is actually not that hard. All you have to do is give a buffer to the reader of writer interface, and every time you're asked for a buffer as a temporary thing just to make it work, you can pass an empty slice. It gets a little bit more complicated with 0.16 because you also have the whole IO thing, IO interface thing. My recommendation for you would be to join a Zig community and ask there for help. So Zig, for example, has a big Discord server that has a help channel. And in there, you can open a thread and ask for help. Actually, I would even say chances are that whatever question you have about IO has already been asked. So I would also recommend that you search, which is both good so that people don't have to essentially, answer the same question over and over. But it's also good for you because if you do find a match, you already you have the answer instantly at your disposal. You don't even need to wait for somebody to answer your question. Alternatively, you can wait a little bit more for the learning materials to catch up. But I would say that I don't know. I guess it depends on your level of interest. If you can do the community thing, that's gonna be smooth sailing right away. Don't even have to wait. Okay, so we have a good list of types here. I want to add more, not just those, but we already have a good list of types. Okay, so what do we do with those? In line 4, types. Okay, what do we do for each type? We do, I think, const res equals Ziggy dot I think it's deserialize leaky. You know what? I'm gonna call this uppercase T. It's a type. It makes sense. So we pass in T. Then I think we pass GPA, and then we pass source. I don't remember the argument order. Type GPA source. Okay, so far so good. Then there's meta and options. Right. Right. Meta and options. So we need to make a meta. Zig deserializer meta. Init. Pass it in. And then options, I think the default ones are fine. And then what we want to do is well, this can fail, so we want to catch. The error should not be so let's assert. Or to be precise, the out of memory error could happen, but I think that in this context, if it is happening, something has gone wrong. So that's why I'm turning it into a crash. Then all the other errors should allow us to call meta. Actually, you know what? I don't even need. I'm gonna leave it there, but I think meta has another assert in it for the same thing. In this serializer meta, there's a thing for reporting errors. Yeah, report errors. Keep in mind, having a deserialization error and it being reported, that is still a success in our book. We expect most documents that come from the fuzzer to be invalid. What we're looking for is crashes. And some errors we are turning into crashes, but not these ones. So allocator options, path we give null, source is source, error is the error that we got in, and then a writer. Oh, but there's also report errors FMT. which I think is the same except for the writer, because we don't have a handy access to a writer, but we can do std.debug.print. This is like really just for convenience. Okay, so this is our starting version of testing deserialized leaky. Try with a bunch of types. Expect them to maybe work out, maybe not. In case of failure, let's test the error printing logic. You know what? Although I'll be honest, this thing is so straightforward. I mean, there is a bit of logic here, but I really do not expect this to really have any bug in it. But you know what? It's eh. Okay, let's do it this way. For now, let's comment this out because let's see if we can find crashes like this. We probably will. If we don't find any crash like this, we will also expand it to this. Incompatible types F32 and void. Right, return. Actually, no. Continue. Oh, it's not gonna allow me to continue, is it? Yeah, motherfucker. Well, here's my ninja move. Break BLK with undefined. Haha. On error, we break with undefined. Because the thing is, we don't want to return because we want to loop again, but I cannot use continue because I'm using an inline for. So I'm just like quote unquote continuing naturally, but with a bogus value because the point is that we're not even using it. For now, this is bad. This is not correct. It's just this is fine only because we do nothing with this value. The moment we want to do something with this value, then this is just a bad idea. An alternative solution here to get out of the continue problem is that we turn this into a function, and then that function will be able to return either return or continue doing things with the value if it wants to. So that way we skip this problem. Although I think that runtime continue could be implemented for inline fours. It's just that I don't know. MLag has not done it yet. Okay, time to fuzz. Crashes in 3, 2, 1, boom. We got crashes. Inline for continue not allowed. Why? Because well, I guess you sent this comment before I said it, but it's literally just because it's not implemented. Or rather, I'm not the person doing this work, so I might be missing some context, but I do believe that continue is totally implementable. Actually, I think I know that for a fact, but it is currently not implemented. And so until that is implemented in the compiler, it makes sense to forbid the usage. Otherwise, you will get a misbehaving executable because that thing is not implemented correctly, but then you think it is because you're allowed to put the operator there and then like the statement there. And so, okay, we have crashes. Fine. What's happening? Attempt to unwrap error invalid character. Parse in for none. So this is a function that can return invalid character, but in this serializer, we think that That cannot happen. I'm guessing because... Okay, let's see what we have in here. Oh, it's the usual E stuff. But we are now testing for it. Also, wait a second. This bullshit is in a comment. Why are you concerning yourself with this bullshit? Um, this should parse correctly. Oh, there's... Yeah, this should parse correctly because this is all in a comment. Oh no. What is going on? Like if I feed this to Ziggy FMT dash, yeah, you see. Oh shit. Where did my boy Zero go? What happened to my boy Zero? So first of all, the fact that this number is allowed, it's oh, you know what? Oh, this is the problem actually. I'm dumb. Yeah, no, it's not E. So there's an E in here, but it's actually bait. It's this that we think at the tokenizer level that it is a valid number, but it's not. Also, wait a second. Why do we have... Wait, we are... No, we're not doing schema anymore. This is Iggy proper. Okay. Um Give me a second. Do we not try to parse integers in the Ziggy tokenizer? Because we do that for some numbers, but not all of them. So there's finished number. Where do we call finished number? Only one place inside of number. Okay, let me see if there are other places where we do not do number. You know what? Actually, we know for a fact that that is somehow accepted as a number because otherwise our auto formatter would not have auto formatted the thing. And also the fact that it ignores the zero at the end, that's also turbo sus. Oh my god. um so 09 moves us to number, minus looks forward whether we have dashes, otherwise it moves us to number. Okay, then in number, yeah, we just allow these things to keep happening, and then we call finish number. And finish number, if we parse int successfully, we said it is an integer. If we fail and then parse float successfully, we say that it is a float. If that fails too, we said it is invalid. This is all well and good. This is all well and good. Oh, you know what? The only thing maybe is that the minus stuff, I think it's bad. I think it should be I64, and we just do not do the minus. Yeah. That still does not answer the question of why do we think that this is a valid number? I guess the answer is that Zig believes that this is a valid number, but I don't understand why is the zero excluded from these. Okay, let me rebuild Ziggy because I have not built in a while, but yeah, I don't think this is it. What happening? No field memory function slice in token. Oh, it's doc dot lock dot slice. Oh, did I just nuke my test cases? I just nuked my test cases. Well, not a big deal. We're gonna find them right away. Yeah. Okay, we have a few crashes already. Okay, so this one gives us unexpected token and invalid syntax when formatting it. And it is just garbage. It's a minus minus zero. Perfect. Pass it to the repro. And again, okay, so this is still the problem where we are trying to feed a token to parsing for none and it fails. So I, I still don't understand why the previous one was fine. But you know what? If the previous one was fine because parse int accepted it, then I think that this parse int or parse float that we're going through will accept that, should accept that also. So I think we're doing something dumb in here. 390. The token was already validated, and parsing floats cannot overflow. I mean, this is correct. If the token was already recognized as an integer or a float token, then this should work. Let's add some printing. Let's see what this looks like. I don't know. GDB and breakpoint instead of printing. This is not repring. Oh, wait a second. This is now not repring. You motherfucker. Why is this not repring now? Wait, are we facing undefined behavior? What is going on? Okay, let me rebuild again. So first of all, I'm on macOS. I cannot use GDB. I would have to use LLDB, which I can do. But it is an option. But for now, I prefer to do debug printing. This is not repring anymore. What the fuck is going on here? So let me look at this again. You know what might have happened? I think I understand what might have happened. The code that I simplified with the minus minus stuff was the cause of that bug. And that fixed it. And yeah, I get it. Casually, this has to do with this thing having a double minus. Yeah, okay. Yeah, that code was stupid. I will admit this. The numbering, the code for parsing numbers in Ziggy is stupid. The reason for this is because I originally wanted to parse numbers using the Zig grammar, so accept the numbers as the Zig grammar allows them to be. And then once I decided to have Ziggy be a superset of JSON, then that had to change because now I have to accept numbers in according to the JSON grammar, and I have not implemented this yet. So I have this essentially to-do hack in place for parsing numbers. So that's on me. So here's what I'm gonna do. I'm gonna reset the fuzzer and start it again. And we got a new set of crashes, so let's fix those. Okay, so wait, what the fuck? So we're still here. Okay, we are back to giant number with underscores and an N in the middle of it that somehow reaches the deserializer. 390. Also, where is my print line? Oh, I removed it. Let's put it back just so that we can see that token. So how comes that this parses once but then fails the second time? With invalid character. So invalid character, especially. Oh, wait. I know why. I know why. It's because we're using parse float no matter what because our outer type is float. Okay, so here's what's happening. In this code, we're saying if I have an integer token or a float token, regardless, I'm gonna parse those with parse float. But apparently the rules are different. Not every integer parses correctly with parse float. That is the assumption that I made in this code, and that is the assumption that we're falsifying with fuzzing. So turns out that you will be able to parse with parse float a float, but there are some integers that only work with parse integer, parse int. But our thing is a float, so we need to do float from int over this. And what is the base of our integer? Base 10, I guess. Although, what about stuff like 0x? Parseint doesn't accept. Oh, there we go. When base is 0, the string prefix is examined. Okay, there we go. So we want base 0. There we go. Wait, can we do the same in here? Oh yeah, I didn't know that parseint supported that. That makes total sense. Okay, finally, Jesus. Okay, so this, I bet you that with this we have fixed the crash. Once we get past programming errors. Access of union field int while field float is active. Expected integer type found F64. Wait, what? Where? What? Oh, T. Sorry, T is still a float type, right? Um, F 32. No, what the fuck am I doing? Sorry. I64, I guess. There we go. And now it's not a crash anymore. Perfect. What does the N111 do? I don't know, but whatever, not my problem, I guess, for now. Okay, let's get rid of this debug printing because we really don't need it now. Okay, I think I'm gonna do another round of fuzzing because I suspect that the other crashes that we saw were all from this class. Fuck, more crashes. All right, let's see what we got. Still, is this still about numbers or are we done with freaking numbers? Attempt to unwrap error invalid literal. So there's a in parse bytes. Let's take a look at parse bytes because we might be missing some guard against the token type. We might be trying to parse as bytes something that is absolutely a token that is absolutely not a string whatsoever. So before we start wondering whether there is a mismatch between what the tokenizer thinks something is and what the corresponding Zig deserialization function thinks might be out of whack. So let's see. Six, three, one. Yeah. This is unfortunate because we are essentially saying so we know that the type that we're expecting is a string, but we're not testing whatsoever whether it's really the case or not, and that is bad. And that is definitely bad. So before we can do this, we need to validate this token. If first dot tag is different than bytes or bytes line, okay, so this should be a switch. And in this case, we do this. Else, we said that it is unexpected. Okay. Oh, and you know what? This is interesting. This is an unexpected value. Let's rebuild it. Unexpected value gives a hint that what was expected is a value, but but if the token is a value token, but of the wrong type, it says wrong value type instead of saying unexpected token because the token is not entirely unexpected. The token is like the syntax is correct in that case. It's just that we expected a type and we found another type. We still crash. Of course, we still crash because we do parse bytes only for bytes. Bytes line. Okay, I'm slowly remembering how my own language works. Bytes line has a different syntax. It's like this. So bytes line. Bytes line is more like return first dot lock dot slice two dot dot. We don't have source. Where's source? D dot source. There we go. Hey, Danaka. Bytes parsing bytes. Yeah, man. Bytes doing all kinds of things with other bytes. Bytes on top, bytes on bottom, 2 bytes on the sides. Ugh. Okay, we still have a test failing. What the heck? Oh no, sorry, it's not test failing. It's a straight up error here. What is going on? Expected type error, blah blah blah. Const 8. What? You're expecting a null terminated string? Are you nuts? This function is wait. This function is supposed to return a null terminated string? Why? I mean, okay, I get it. It's supposed to return a null terminated string because somewhere there is a usage of this function where the type provided from the outside is a null terminated string type. And that's definitely not what this guy is returning. Sorry, is this guy doing it correctly? Wait a second, motherfucker, parse bytes does handle bytes line. So wait. I thought, you know what? I forgot that is a function that I've implemented. So it should handle bytes line. Oh, are we missing the info sentinel stuff? No, we're not missing the info sentinel stuff. So what do you want? Also, I think this is copying the string even when it's not necessary. Oh, no. No. I'm wrong. Holy shit. Oh, man. Good thing that I'm walking back the garbage, the mess that was setting myself up for earlier. This is the correct logic. Okay, so how is this failing? What is going on? I have not understood correctly the problem here. We need to work harder. How does Zig handle strings, by the way? Always a bit annoying when you combine C and Rust, that they treat strings very differently. Zig does not have a type for strings. Strings in Zig, as far as the language is concerned, is just a array of bytes. Then, if you have extra rules on top of that, such as these bytes need to follow one encoding as opposed to another, that is kind of on you to do that in userland. There are the stdlib functions, for example, that deal with paths. They have knowledge of the specific encodings of paths on the various OSs and whatnot. I'm not claiming that they implement everything correctly. I'm actually genuinely not sure. But the point is that it's not like we don't know that there are contexts where, like, there are quote unquote OS strings. I believe those are called OS strings in Rust. You can correct me if I'm wrong. So we understand that. But this is not, none of this is in the language. It's entirely userland. Oh yeah, sorry. No. Okay, so when it comes to this stuff, this is actually fully encoded in the type system. Yes. So the way it works is that this is an immutable slice of bytes. So you could say that this is, kind of your vanilla string. Then if you need to have null termination, so like if you have a C API and the C API only accepts null terminated strings, otherwise it's an error, you specify it like this. So you put the colon terminator, let's say colon sentinel, is how you express this kind of thing. It doesn't have to be 0. You can have also, this is an A terminated string, so you can specify these things as well. And like you can put essentially a scalar of these guys in here. You decide which one, and then you can put that in function signatures. And then every time you have functions that manipulate strings, for example, slicing will drop the null terminator unless you assert that slicing operation will maintain the null terminator. There's syntax for it. So this is me taking so this dot slice is just a function, a userline function that I've implemented. That this slice function takes a token and turns a token as in start and end positions in a string and gives you a actual slice of that string. Then here we are chopping off the 2 initial bytes. So this is like the built-in slicing operation. If we want to say that a slicing operation maintains a null terminator, you have the syntax. This is an assertion though. So it means that you're stating as the programmer that this slicing operation will have a null byte past the end of the string. In safe modes, so debug and release safe, if this assertion is falsified, so there is actually no null byte past the end of the string, then you will get a crash. In other modes, in release fast and release small, the assertion is not going to be present, and there's actually going to be, it's going to be used for optimization. So essentially making a mistakes will cause misbehavior of your program. Without a sentinel, it would use a length delimiter to track the length manually. No, slices always have, so slices, so these guys always have in them the length. So this has both a length information in it and a null terminator at the end. If you want a pointer, so not just a slice is pointer plus length. If you just want a pointer, this is a pointer to a unknown number of bytes, while this is a pointer to a unknown but null terminator number of bytes. Sorry. So this guy is essentially a C string, a null terminated C string. This guy is a pointer to an unknown number of items, and the expectation is that somewhere else you will know how many of are there, and you will know how to stop essentially iterating those elements. And this one is a slice, so it also keeps length around, because a slice is essentially this. It's this conceptually. So this is essentially this, and this is this. Yeah. So this part is done. Tracking null termination in the type system is goated for C interop. It catches so many mistakes. It's not perfectly foolproof. You can put an assert, a wrong assertion, like you think that your slicing operation keeps the null terminator around, but maybe you got it wrong and it doesn't. So you will catch that with a runtime panic. It's not guaranteed to be true at compile time, but I mean, I guess obviously, because if you're fucking around with strings at runtime, obviously you can fuck around with strings in the wrong manner, and you only discover that at runtime because that is an operation that is based on runtime information. But in practice, it's really, really good. And the thing is, the null termination very often you don't want to use it in your programs. It's kind of a C-ism oftentimes. But there are some key moments where a null terminator at the end is actually genius. If you're writing a parser and your file format is not meant to be embedded too often in other documents, so let's say that you're making JSON parser, for example, it is a good idea to request a null terminated string for that JSON document, because that can simplify your tokenizer a bunch. It's actually pretty good. Okay, so why is my code acting up? Why are we somehow landing in invite literal from parse bytes? 779 unreachable. To avoid unnecessary copies. Yeah, indeed. I noticed. Parse alloc slice. I recently encountered an alternated array in a C API that was something new for me. I can guess what it might be. An alternated array of null terminated strings is your boy CLI arguments. It's your argv. Like argv in C is what is it? Whenever you have an argv, I think the type is something like what is it? Char star star char star star argv. I don't remember how they write it down. I think this is it. Is it not? Oh no. Okay, they do char star square brackets. I guess that's one way of doing it. But it's the same. I believe it's entirely equivalent notation. So char star argv square brackets. But in any case, how do you write this down in Zig? Let's see, not quite, but somewhat similar. Okay. It was for statically allocated data that exists throughout the lifetime of the library. Okay, so something of that kind, like an array of strings. And so since it was doing everything through null termination, it was a 0 byte for the strings, and it was a null value for the list of pointers. So this bad boy in Zig is this. So first of all, also another thing that you don't know is, can this pointer as a whole be null or not? That's another thing that C doesn't really tell you. So it's like this. It's an optional null terminated. I'm also going to say const. I don't know if this is mutable memory or not. I believe it's not mutable. So it's a optional null terminated. Not a slice, because it doesn't have len. It's a pointer. So it's a null terminated pointer to many pointers to null terminated strings. So I believe, and actually this is also optional. I believe this is, let me think about it for a second. Can this be optional? You know what? I'm not sure if this can be optional or not. I think yes. I think this is the signature. This is the Zig version of this. But keep in mind, this is leaving a lot unsaid. This is being a lot more precise about things. So, for example, mutability versus non-mutability, this is encoded explicitly. This is just left as an exercise to the reader. Null termination, what the sentinel is, this is written here explicitly. It's not left as a exercise to the reader. Same with null termination. So like you could do something like this, right? to simplify it. Consuate. You know what? Let's even drop the cons. So you could do something like this. Like this would be the much simpler version of this, but here you're losing information about what the sentinel should be. You are saying that these things cannot be null. If the outer array is null terminated, then the inner cannot be optional. Yeah, you're right. Yeah, good point. Thank you. There you go. Now you know that I'm not so sure though, because this optional tells you whether this pointer can be null or not. The first one. Whatever. In any case, that's the C type madness. Yeah, totally. I mean, you do the other one. My point is there is more stuff that you have to type out, but because you're encoding more information in a explicit manner, the other one is just I don't know. C has a type system that is, I don't know, it's funky and just too weak. Really, and I get that some of that helps with being more agile when writing things. Like you have to type fewer things, and you can do things in like a one liner in one operator in a way that Zig would annoy you about. Um, yeah, but the type system, but I even accounting for that, I still think that the C type system is just too way too weak. Well, it doesn't have a type system at all. Well, you know, it's better than JavaScript. at least at least if you try to add a string and a number, it will not, it will complain. Actually, will it? Because the string is a pointer, you can do math on pointers, so never mind. Actually, it does allow you adding a number and a string in a sense. I don't know. Okay, so why are we hitting this? God damn it, man. I'm starting to think that slice here is omitting okay, let's look at our test case. So what does our test case look like? Okay, so this is a string that contains a bunch of garbo, but then there's other stuff afterwards. Oh, but you know what? Since we're tokenizing and we are like deserializing as we go, uh, this is the token that we're dealing with, and this is, I believe, what this function does not like. I wonder if what we are doing wrong here is essentially, I think that we might be passing down the string with the quotes, and we might be supposed to be passing down a string without the quotes around it. So how do we test this? Let's do two things at once. Let's print this bad boy so we can see what it is. And second, let's slice it up. And let's see what happens. That is the output of the fuzzer. So the madness in here. Yeah, by the way, these are 1, 2, 3. So actually, this quote is kept in, and I believe that the token ends here. Actually, the token ends. It should end on the second on the second quote here. We're failing to compile. No, we are crushing hard normal stuff. Okay, so everything is breaking. So no, we do not slice this normally. So what the heck is going on? Okay, I think I understand what is going on. Um, 1 plus LO compiles just fine. Yeah. Unfortunately, I was trying to say something good about C. God damn it. Yeah, but because the syntax is moving forward with the pointer, right? So that's actually it's not as dumb as it is in JavaScript. Nevertheless. Uh okay, did we build? Yeah, we built, but then we failed all tests. That's fine. Let's see what happens now. Okay, that I was correct in saying that this string would contain everything up to this second thing. I am surprised that this is considered a invalid literal. It means that there are some rules about these slashes that we are not recognizing correctly in the tokenizer that Zig instead complains about. There we go. Invalid escape character F. That is the problem. That is what we're not doing in the tokenizer. Oops. So here's how we're gonna get past this hurdle temporarily. Because again, unfortunately, I know that I need to do this at some point, but for now, all these, let's say, more nuanced rules about strings and numbers, I'm fine with essentially approximating them with having hacks in place temporarily. So let's go to bytes. And in bytes, here's what we're going to do. Once it's time to return, we use the Zig built-in function to decide whether we want to commit or whether we want to consider this token invalid. So essentially, we go into the serializer. We copy this. Actually, we'll want a slightly different variant of this. Can I have parse non-alloc? Is there a non-alloc version of parse? Parse write. I guess I can give it a null writer. There is no validate, is there? Parse escape sequence, parse char literal. Is it parse write or writer? I think it's parse write. Okay, let's do parse write on a null writer. Oh, what's the writer first? Disgusting. Null? No. No op. Discard. Discarding. How do you make one of these? It wants a buffer? Count. Oh, this motherfucker counts. Okay. Okay, give me a second. Let me see what other writers we have at our disposal because this one is fine. I wonder if there's an even simpler one. So discarding counts, but then discards, I guess, past the end of the given buffer. So it's like a fixed buffer, but then it discards. Considering how the interface works, you can really implement discarding better. No, of course you can. Okay. No, right, you're right. Because you are not. So this is not the interface. This is an implementation. So you are not required to request a buffer here. But when you chain this with other things, they might have opinions about you having a buffer or not. So I that makes sense. For flexibility, you need to be able to provide a buffer that satisfies other constraints in case. Fine. Var discard is a discarding dot init empty buffer, because in our case we really don't have any constraint of this kind. Okay, what's your problem now, dude? Mm, what is the problem? Is it in here? No. Okay, what have I done? Oh, semicolon. And there's a switch. Oh, wait, I copied some of it. Um, okay, like this. True, else, false. Okay, also wrong. You know what? Let's change this to valid. Okay. We're crashing hard. What the fuck is going on? Oh, would you look at that? These talking about buffer requirements. Is this it? Is the problem buffer requirements? Assert that bytes.len is greater or equal than 2, and then bytes 0 is a quote. Are we not doing this? Oh shit. Yeah, we're not doing this. Oh shit. No, we're doing everything wrong. Oh my god. Oh my god. So how do we do this in a nice manner? How do we do this in a nice manner? I guess we can do this. Okay. Oh, we're still filing. Sorry, we're still failing these things. What the heck? Um. Oh no, yeah. Look, this is totally wrong. There we go. So we still have this problem. That surprises me. That surprises me a lot. Ouch. That really surprises me. Uh, because I would expect now the tokenizer to catch this and consider that an invalid token. Hmm. 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 So. Hmm. 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 Let's have some debug printing, I guess. I don't know. Let's see where that gets us. I'm a little bit weirded out by two things. One is, why are we invoking the tokenizer so many times? Oh, I know why. We're doing this once for every type. Okay, so what's happening is we are trying to parse these as a bunch of numbers. We keep failing because um, the type doesn't match. So we don't even attempt to look deeply into it. Then we get to this time where we try to parse this as a string, and this final time we do get a thumbs up the from the tokenizer, but then somehow we get invalid literal the second time around. What? What is going on? Yeah, this is literally it. No change whatsoever. but it returns invalid literal. Why do we think here that this is fine? And why do we think there that this is not fine? It seems the same thing. I can even do this. I'm gonna remove this equal sign so that we can have a print that is even more aligned. We are using this same exact value str in here. To be fair, here we're doing parse alloc. There we were doing parse whatever. There's a disagreement between these two things somehow. Okay, let's maybe give a buffer to discarding. Maybe that is what's causing trouble. Asserts that bytes has a quote at the beginning and the end. Okay, so we know that now we were supposed to pass this, but in any case, an assert would have kept us honest. You had not done this correctly. So what is this guy doing to the writer? Yeah, it's not doing anything to the writer. It's just writing to it. I am so confused. Also, don't tell me. Yeah, parse alloc makes an allocating writer out of the allocator, and it does the same exact freaking thing. I'm confused. I am really confused. So now I wonder, I'm going to move this code here. Let's do a parse write first then. And sure, let's do a discard writer. Or let's do an allocating writer. It doesn't even matter. Oh, we don't have a GPA in here, do we? Oh, we do. Okay. Address comparison instead of a string. No, I don't have an equal sign. Um, I'm failing because parsing at the tokenizer level has seemingly a misalignment with what the Zig string parser accepts. And that is weird. Now we get through also from str. Am I somehow using the if statement wrong? is even slashes causing the issue? I don't think it can, because even slashes causes the tokenizer to continue recognizing the string. So with this, how can I say? With this, you're not exiting. You're only exiting if you encounter a null, but that's going to be an invalid token. You can exit if it's a new line, but that's going to be an invalid token. And you can exit, that's it. You can only exit, the only exits that there are these two as an invalid token, or this one as either a bytes token or an invalid token. And in the other places that we're at, like the serializer, here we are already checking that we are in the bytes case. So we're receiving a bytes token. This is not an invalid token. So I don't know what I'm doing wrong. I really do not know what I'm doing wrong. Also, why is parse alloc? Parse alloc is failing. Let's turn this into a parse alloc. I don't know how, but let's do it twice, I guess. I'm weirded out that this so far has been going through, and this has been erroring out while passing seemingly the same thing. And the thing is, here I'm using parse alloc. The other place I was using parse write, but but I mean, it's essentially the same thing because one is implemented in function of the other. Oh my fucking god! Now it's giving me false. How? How is it? I I'm going crazy. I feel like I'm going crazy. How is it? How is it that this one doesn't say anything? This one says something. Oh, I'm an idiot. It's because parse write is not erroring out. It's giving me a result. Of course. Okay. Now we got why. So parse alloc gives you a Zig error when there's an invalid literal. Parse write does not. We cracked the code. We cracked the code. So this is fine. We go into the tokenizer. We use parse write, but we don't really catch these, or rather, let me see how we can do this. I think I think we do it like this. Token.tag, and then we switch over this guy. And here we catch with dot failing or something like this. whatever the standard library does. Success, failure. I'm not gonna add a new error. Okay, so we switch over these. Over failure, tag is invalid. Success, it's bytes. Okay, I think we have finally found peace. Once we fix coding errors. What is your problem? Incompatible type, string literal result, and tokenizer and struct. Come on. This is not that anonymous. This is really not that anonymous. It's really, it's not grabbing the same result location. I guess that is the problem why try doesn't work with the coliterals. Sorry, why catch doesn't work with the coliterals, I guess. Okay. Expected type literal error. Wait, maybe this is why it wasn't working. Oh shit. Okay. Um Wait, maybe this is why it wasn't working. Okay, so failure is a what are the cases here? I don't know. Empty char literal. Okay, what do you say now? Does it match? It doesn't match. Oh. Okay, seems that we finally made it happy. And now the repro doesn't crash us anymore. Awesome. We probably have fixed all of them. So yeah, this is good. This is good. Let's restart the fuzzer. Okay, I'm gonna quickly go to the restroom and refill the water while this runs. Let's, I don't know, let's get it to 5 million, 10 million iterations, and hopefully let's see if it finds a crash. If it does not find any crash, then we can complicate this test routine and we can start introducing the auto formatter maybe back into it to round trip deserialization and serialization. We want to make sure that those two things don't lose data, right? And also, it's just a good excuse to exercise the serializer because the serializer might, I don't know, fuck something up. So I'll be right back. Okay. It seems that the fuzzer is not finding anything else useful. That sounds good. Let's increase complexity. So, fuzzer code. We're trying to fuzz all these bad boys, but now we care about the result. So how does this work? We need to factor this out into a function necessarily because we have to use inline 4. So deserialize deserialize t GPA source, I guess. Considerate, and then this is void because the what the fuck is going on here? Huh? I'm typing V. Why does it show me B? What the fuck is going on? Oh no, flow. Hello, Phil. Okay. Deserialize leaky. Oh, we were saying if we don't find any other error, let's test meta print errors. So we're gonna do this. And in this case, we don't break with anything. We just return. No BLK. Okay, so this is already a slightly more complex version of what we were doing up until now. So let's test this. And maybe we can kick this off. And in the meantime, we introduce more stuff still. So we want to do the round trip. The problem is the round trip has to succeed, and then we need to we need a equality function. You know what? Here's how we do an equality. Oh, I have it. I have the actual good equality function. We don't test equality through FMT. That doesn't matter. What we want is testing equality by round tripping on the deserialization code itself. We want to test that the two values are the same. Yes. Oh shit. What? What is going on? Why are we crashing so hard? Unexpected token. Unexpected value 00. Unexpected token panic reach unreachable code. Did we just find a crash while printing? Delightful. So there was something wrong in our error printing logic, huh? Look, we are panicking in the middle of printing unexpected token. Or actually, I guess this is right after because we don't... when we do unexpected token, I don't think we show the unexpected token. But actually, maybe we do. I think these error return context. Okay, so we map it to unreachable. Okay, so this is the error trace. And then we hit unreachable here. 130. Yeah, the serializer 130 sounds like the formatting code. Well, what do you know? So what is happening? We are saying, oh, this is a known field. What? How the fuck did we get a known field for a field name that does not start with a dot nor a quote? Oh, no, wait. There's a lot of stuff. Okay, okay, okay. Give me a sec. I think I have collapsed too many things into the same code. And so that has falsified this switch. Well, these are unreachable to be precise. So what we're doing here is if it's unexpected token, if it's unexpected value, if it's duplicate field, if it is a known field, then we're saying if the token is empty, it's an EOF. If E is not an expected value or unexpected token, okay, so let's turn this into an actual switch. So we want to do this thing for error dot duplicate field, error dot unknown field. For these two, we want to do this shit here. For the other cases, we don't want to do anything. Overflow, sorry, the other case is essentially unexpected value, unexpected token. You know what? Let's put them explicitly. Okay, in those cases, we do nothing. Okay, this should have found that error. This has fixed that error. Not bad, not bad, not bad, not bad. What's your problem, man? Oh, yeah. There's technically the error set is technically bigger than that. Yeah, sounds good. Boom. These now does not crash anymore. So fuzz again. Okay, with these fuzzes, let's go expand our fuzzing routine because we know that, I mean, yeah, sure, we found this problem. I don't know, maybe there's another bug in there, but there's not a ton of bugs. There's not that many lines. So we're not yet at the interesting point of this routine. We want the full round trip. So the full round trip is if we succeed at parsing, when we succeed at parsing, then we want to, sorry, when we succeed at deserializing, then we want to serialize. That has to succeed. So that has to succeed, and deserializing again should both succeed again and produce the same fucking value. So hopefully we have some kind of like meta equality function that we can use at our disposal. Otherwise, I guess we'll write it ourselves, but it shouldn't be hard because in any case, our types are dealing with we're dealing with simple types. We're not dealing with complex types in here. So also I need to add more fancy types. Like I have a struct. I don't have a list of structs. I should have that. And then we should also introduce after all of this, we should introduce also um, the dynamic map that Ziggy bundles, because also that one has its own parsing logic, which is probably which also has probably its own fair share of bugs. So we should look into that as well. So deserialize as, or let's call it test deserialize type. So test deserialize type. Var allocating writer init on GPA const writer or W. Then we want probably to do Ziggy serialize res, I'm guessing, and W. Maybe there are some options. And then this can fail. But failing is should be catch unreachable. So let's do catch, print what went wrong, and then unreachable. So we print input and the input is source. Then maybe we can print the error. Actually, how does serialize work? I don't remember. What's options and then writer? Fine. What does it give me? Interesting errors? IO writer error. Oh, interesting. I should put this also here then. So, long story short, it's serialization is not expected to fail at all ever. That makes sense. So this catch error is not particularly interesting. So it's essentially just going to panic. That's what it is. Okay. So catch unreachable. So if it goes wrong, it's a catch unreachable. Frankly, printing the input in that case doesn't even matter, I guess. That's fine. Also, the order of things here is different. Then, so now we have the output in, so it's something like const round one equals AW dot to owned by Sentinel. Catch unreachable. Okay, so now we have the round one output. I'm gonna leave this there so I can reuse it. And so we can call this meta one. Put everything in meta one. Actually, you know, it doesn't even matter. We can reuse meta if we want. You know what? We can say meta equals init. And then we use meta still. That is perfectly fine to do. But instead of source, we pass in round one. And we expect res1 to be equal to the other one. So if not, std meta dot equal. Oh, is this a delightful super auto magic equal? Compares to of any type of equality containers that do not support comparison, or there are no compared field by field basis, pointers are not followed. That is fine given the types that we have. Do you do strings as you should? I would assume so. Pointer slice. No, bro. No, bro. The fact that it doesn't do strings means that this is not what we want. Oh, come on, give me an equal. Give me a nicer equal. Do you really expect equal enum? Oh, that's internal stuff. Really? You only have this lousy equal here? Boo. I disapprove. I disapprove. I guess we need to do equal deep. Oh, you know who has these? I bet you that testing has these. This motherfucker. This function is intended to be only used in tests. I'm kind of using it in a test. Where two values are not deeply equal, prints diagnostics to STDR to show exactly where they are not equal and returns a test failure error. Please tell me that it is not asserting that we are in a test. It doesn't seem like it is asserting that. So maybe we can use this. So expected is going to be res, and the other one is res1. And then we catch unreachable. And I think we don't even have to print anything. No, actually, this catch, we don't want to do something with it because this is going to show us a diff based on the value, but it doesn't tell us anything about it doesn't tell us anything about the original text, which is something that we might want to look into. And you know what? Let's do original, and let's do round one. Okay. So this fuzzer has not found anything in the meantime. That's fine. Let's rebuild this. Oh, this is going to be good. We're probably not going to get often past this track. But when we do, it's going to be good. Also, wait a second. We do a deserialize leaky again, and if this fails, we complain. No, this is catch unreachable, my boy. Yeah, this is a catch unreachable. Or you know what? Maybe we can print the diagnostics just so that we get an idea. So, um, yeah, we print this just so that we can see it. Oh, you know what? Maybe we print this first. First, we print this. Then we print that, and then we do unreachable, because this second error is absolutely unreachable, but maybe that is more context that can help. Okay, let's see. Again, one critical like problem with what I'm doing is that we are not getting often past the initial hurdle. So we need to be aware of that. The fact that his iteration speed is going down seems good. Although that went down a lot. I wonder what freaking cursed thing we were hitting there. Out of curiosity, I'm curious to see. Um, I'm curious to introduce a regression ourselves here. Like, I want to see how often we are actually surviving this far. So here's what I want to do. I think I want to take RS1 and modifying it. So if it's an I32, we increase it by one, which should make us fail the equal dip. Let's see if we get there ever. I'm currently fuzzing a piece of code, and so far I found a lot of bug in my fuzzer. Nice. How is your expected value for the fuzzer speed? Um, so far, 20,000 iterations per second has been around where I've been hovering. It has been 27,000 iterations per second when doing something simpler, a little bit less when adding, more stuff after the initial parsing. Um, but it is kind of where I've been hovering. Okay, I thought that we weren't going past that threshold too fast, too quickly, but we are. These are all crashes that I have introduced myself right now. So we are getting past that threshold with simple numbers a bunch. That's good, I guess. Um that seems good. So here's what I'm gonna do. Let's make this a little bit more unlikely. So let's do only F32 and I32 and bool. Let's remove a bunch of these options to simplify things. And also this is supposed to be slice of bool. Let's simplify this and let's add more structs. Let's add a struct that has two fields. Let's add a struct that has three fields. Let's add one that has default values. Yeah, that sounds about right. Um, what else can we test here? Technically, we could also do unions. So the same thing that we're doing for structs, we do for unions. Except that unions do not have default values. Okay, let's see how we're doing now. Right. It must be tagged. Oh, well, guess what? We had a compile error. We are using default value and it expects one argument found 0. The fuck? That's a new change that we weren't able to test. 692 in deserialize. Yeah. Okay, what does default value want? It want it wants utters, and then it wants the field type. Uh oh, but we already okay. It wants F type, which we're missing. Are you happy now? I'm painting a real thing and reproducing an elusive bug I saw in prod, but for some reason the fuzzer is exiting without leaving a crash file behind. Any idea what could trigger that? That sounds like a bug in the fuzzer. Because technically, when the fuzzer, what you do with the fuzzer is that you put the input text into a memory mapped file, right? So that on process cleanup, that data is written to disk no matter how you crashed. So I'm guessing you're crashing behind reaching the, before reaching that point, right? Why is my thing so messed up? RM? Oh, because there is no out. Okay. We're crashing a ton. Okay, this is still because of the crash that I left in there. So let me undo my crashing. Actually, you know what? Let's see how often we get into the struct A case. So if the type is, you know what? I'm going to move these guys to the bottom. Yeah, I'm going to move these guys to the bottom so that we can index into these more easily. So let's say that this is type 0. Undeclared identifier types. Oh, it's because they're in there. Ah, that is unfortunate. Um, okay, let's do type info. Okay, let me then undo this. Let's do type info. And in the struct case, we do res1.a plus equals 1. Else we do nothing. Okay, so this is saying if you give me, if the type is a struct, we're going to increase its field A. And in all of these cases, increasing A is viable. So we do it. Let's see how often we crash. Oh, type info of type of. Actually, it's essentially T, right? Is there an API to tell the fuzzer you're done smithing and have started the test? Huh. If you are talking about Zig, I'm assuming you're talking about the fuzzer, the Zig fuzzer. Is that it? The Zig fuzzer does not have that, and I think that is a good point. Although, what's happening more likely is that the Smith should be consuming what is already in that range of memory. So I don't know. I don't know precisely how it works. I'm just guessing. Okay, look, we are hitting some crashes. These are all the times they were getting into struct A. That is actually not bad. Okay, let's find how many times we are getting into a union A. Whoops. Yeah, so if you're using the Zig Zone fuzzer, I would say it is definitely not unlikely that there is something that could be like it's a new implementation, so there might be something wrong in the fuzzer that essentially causes it to crash before it reaches that point. There is a flag. There is a flag to have the fuzzer runner be built in debug mode. Um, it's it's no, it's not a verbose one. Nope. Debug package config. Nope. Um, no debug log. I think build ID. Nope. Mm-mm-mm. It might be something only available in a debug build of Zig. Is that it? My Zig 2 is obsolete. So there's a flag to make a debug build of not just the fuzzer but also other stuff that includes the fuzzer. But I don't see it here, so it's probably something that requires a debug build of the compiler to do. Oh yeah, that's fine. Okay, so we we've done this. Let's see how often we get into the union case. Oh, we're not getting into the union case much, huh? Because it is harder to get into the union case. I would expect it though to get in there or uh occasionally. I'm out of curiosity, what happens if I give it a hand? What if instead of this garbage, I give it a hand with the syntax? So something like, let's see if it likes any of that. Yep, there we go. Okay, so I'm assuming that this crashes is the fuzzer getting into the union case and triggering our expected equal. Yeah, there you go. So this is actually helping it out. Turns out that providing the fuzzer some good starting points makes it more likely, makes it easier for the fuzzer to get into the good stuff. Reasonable, fair. Um, okay, let's remove our source of crashing and let's hunt for actual crashes now. We did learn something though, that it does get past this initial hurdle, and it is not obvious. And we've seen it doesn't get past that often, because if it's doing 20,000 iterations per second and it's getting past, and that number was going up like not that much. So there's definitely a lot of filtering going on, but it is a barrier that the fuzzer is able to surpass. So better than nothing. Let's just put it that way. Okay, can we get now some organic crashes? Um, so we can leave it running for a while. This is a good testing routine, so I'm satisfied with it. This is all good. By the way, we are very far from having exhausted the fuzzing stuff that we can do on this project, because this is all fuzzing without a Smith. We are essentially stressing tokenizers more than anything else. We want next to have some fuzzing routines that stress test the parser more than the tokenizer, where essentially we are using a system that makes it significantly more likely for the fuzzer to output a valid tree. Actually, not even just significantly faster. Sorry, we guarantee that the fuzzer produces valid tokens only, which makes it much more likely that we exercise the parser in a correct manner, instead of essentially doing maybe some of that and then boom, invalid token, which breaks the whole thing, or rather stops us short. So it's a way of making it easier for the parser to go deeper into the valid input space, or rather valid token input. Then we'll still not be particularly more past that, we're not going to be more likely to produce valid ASTs. That's still going to be uh, very randomized, and which we want to, so that the fuzzer can do its job. So we are missing definitely that, and that should be done both for Ziggy, the language proper, and also for the schema language. Oh, we got we got 2 crashes. Let's go. Stupid fucking non not equating to itself ever. God damn it. Uh that is arguably a bug in the expect equal deep inner function, because I think that for the purpose of this function, none should be equal to none. Interesting. So it turns out that the crash, at least this crash that we found, was actually not a real crash. It's a bug with our own testing implementation, and that is another example of none. Curious that it's considered a different case. I mean, it is different. This one has a space. This one does not have a space. So deduplication of crashes happens, is done by the fuzzer, but I guess it's not, perfect. So it seems that we're good essentially. Okay, what do we do in the meantime? Um, by the way, here's the thing. Technically, we could even have these tests all run at the same time, although obviously what you're doing with Ziggy and what you're doing with the schema is different. So probably if you do this, um, you want these two, you don't want this one. At the same time, at the same time, um, this is also more interesting with a smithy than, like, having both is better if you have a smithy rather than sorry, yeah, a smith rather than completely random text. But oh well. Yeah. So mm, found the third crash. Is this another nan? Yeah, it's another fucking nan. Okay, so it's finding the nan verse, but it's not finding other crashes, at least for now. Cool. Oh, here it's saved angs. Oh, this is where I can see this. Okay, so it's either this. This is redundant, and also I don't know, findings in depth. I don't know why I'm used to looking at this number rather than this one. Huh. Okay. Let's say that there is no next big crash for us to fix. What do we do with this project now? Well, the LSP was not sorry, the auto formatter was not kicking in flow, right? What is going on there? Is this my fault? Is this Flow's fault? Flow's fault? Oops. Um, What's up with the LSP? What's going on with all this stuff? Oh, found another one. Still more nanning around. There is one thing to be said. I am not. One could argue that it might be a bad idea to support non-literals in the serialization format. In fact, none is kind of indicative of a bug, isn't it? Yeah, okay, so it's just finding nuns. Something to think about. Okay. Yeah, this is again the same thing. So this is all going well and good. It's just the freaking nunning around. Okay. So what's our next stop? Yeah, looking into the formatter and the LSP stuff. We can leave this running maybe. Although it really looks like it's just finding nuns. That's all it's finding. Okay, let's leave it running there. So what do we do? Why is our Ziggy stuff not being picked up? So F repro Ziggy, save. This is not formatting. Language show completion of the cursor. Language format, file, or selection. Not happening. Why? Well, there's why. Wait, did I not build Ziggy since fixing that bug? Oh, there we go. I'm confused though. Why is this not? But the Ziggy FMT thing now does it correctly. There's these stuff being printed. Maybe this is the problem. Also, this is saying wrong field style. Wait a second. This is saying wrong field style. That is categorically wrong. This is the right field style. Oh no. We flipped around we flipped this condition completely around somewhere because this is totally right. Oh no. So like it's essentially semantically wrong in a way that the fuzzer has no way of knowing. So let's go into AST. Look at field style stuff. Style mismatch. If it's a struct field and the token tag is bytes, if it's a dict field and the token tag is an identifier, oh, wait. How am I fucking this up? Oh, you know what? Also, this is if current is empty, which makes sense because if current is not empty, it means that we're closing this node. So we're just doing this and it is fine. I'm flabbergasted. How is this wrong? Well, let's go figure this out. So the input, oh, no, wait. Okay, no, wait. Okay, I'm not insane. I thought I was insane, but I'm not insane. This is the correct output. Oh, you know what's going on? The fact that we're printing on standard error is preventing the formatting from going through. Because this is printing to standard error, but it is succeeding. So I think that what we should do is there like no fix-ups? Okay, there isn't even an option to disable fix-ups. So that means that if we're calling Ziggy FMT should not print field style error messages. So this is in the CLI of FMT. What we're doing here is format file fallible. I think this is in particular if we're running in std out mode, I think. Let me think about it for a brief second. If check. Okay, let's go from the top. Okay, different modes. Here's format Ziggy from std in. Go to definition. Format Ziggy. Okay, there we go. Here, if error dot dot what? dot tag. If error dot tag is wrong field style, we skip it. We continue if it's wrong field style because we should not be printing those. We are the ones who are gonna fix those. They won't build. Here in the meantime, we're not finding anything. Oh, iterations have gone down significantly. Oh, we have saved 6 hangs. We saved 6 hangs. Those are delicious. Those are probably good stuff to look into. Okay, so now if we do this, just the output. Motherfucker. It's still not running. But the CLI works. The CLI totally works. So this is flow. This is flow. How do we do this? How do we do this? There a setting, some kind of config, file type configuration, Ziggy. Hit a fucking second. How do you do this? How do you do icon equals this? What the fuck is going on here? Is this like a Unicode value that happens to be Zig in some cursed font format? That has to be it, right? Formatter null. Language server null. No. There you go. Well, that explains it. Oh shit. Doing it wrong. Is this Ziggy FMT minus? I think this might be it. There we go. Success. So now the formatter works, and check this out. If I change the container type and I turn it into a struct and I save, the auto formatter automatically fixes the field style for us. Pretty good. Pretty good if I say so myself. Does anyone know why ZigCC generates slower code than Clang when in O3? Add the -- verbose flag, or look at, there might be also other -- verbose something flags. Turn them on and look at how the different CLIs are being invoked. Maybe that will give you an idea. So, also make sure that you're linking against the same libc, because maybe this is it. I think that ZigCC will, if you do LC, I think it will automatically target muscle. I might be wrong, But double check that you're not targeting muscle with ZigCC and glibc with Clang, for example. There we go. I'm using ZigCC to target the oldest glibc possible. Okay, so you're okay, but which okay, and then which glibc are you targeting with Clang? I'm assuming that you're trying to do this. You're targeting the same glibc with Clang as well, right? Because if you're not, then you're comparing oranges to apples. Clang doesn't allow this. Then that might be your answer. Maybe not. I don't know for sure. I don't think there should be any big difference when using Clango 3 and ZigCC. Actually, if you're targeting your local machine, so if you're not using target, then ZigCC should produce a better executable than Clang, generally speaking. But then if you're cross compiling and then you're targeting also different versions of glibc, when I use the latest glibc, same as on Clang, it gets lower performance. Okay. Yeah, I don't know the answer, unfortunately. If you join a Zig community and you open a thread about this, like if you go to Zigit, this is Zigit, zigit.dev. Um, if you open a thread about what you're experiencing and you give people a repro also, um, then maybe you will find somebody who can help you. Okay, so what about the schema LSP? Yeah, we also have the schema LSP. So I don't know, schema.ziggy schema. But you know what? I bet you that the file type configuration for Ziggy schema is not complete, just like the other one. Yeah, formatter Ziggy. I don't remember my own subcommands. It's Ziggy FMT, and then there's a flag, right? std in schema. There you go. Oh, language server also. Wait. Ziggy LSP. I'm guessing is -- schema. Um. Oh no, right. The LSP has cats with the servers with the editor, so this is fine. First line matches prefix, first line matches content, first line matches protocol standard, simple. Interesting. Okay, so let's edit also normal Ziggy. Let's give it an LSP as well. And let's move. Let's change this to schema. Repro.ziggy schema. Repro Ziggy schema. LSP failed. Uh-oh. How's this LSP going? Is this LSP doing any better? Oh, there we go. But I'm not getting suggestions. Okay, so we need to do some work on the LSP. I think it's been a while since I used it, and there might be stuff that is a little bit out of work in the meantime. You know what might be genuinely slower going through ZigCC than Clang? The compiler RT stuff. That is the only thing that comes to mind. So, for example, memset implemented by us is different than the memset that you get from Clang. Um, and I think I don't know where does the memset they get from Clang come from. Is that in glibc? I don't remember. But in any case, there's a few different implementations, for example, of memset floating around, and I think ours is not the most performant one. There's an issue open for that, so maybe that's what you're feeling. In the performance difference. I mean, I'm not sure. Sorry, did I say memset? I meant memcopy. Sorry, memset. I think is never mind. I think the memset is not particularly complicated. It's memcopy, the one that has more nuance to it. Sorry, I mixed them up. Yeah, it's memcopy. I think the main culprit more than anything else. Or every time you have a for loop that essentially implements a memcopy, because that usually gets optimized into a memcopy. Okay, so I think we're doing fine. Let's find let's stop this. Let's take a look at our hangs. Why are we hanging? Why are we hanging? So these are all nuns. That's fine. Haha. Ouch. Ouchie, ouchie, ouchie. We found some infinite loops. So the fuzzer keeps delivering, man. It's just so good. It's just so good. Like you don't even need you know how people say, "Oh, you don't even need to be good at programming because they don't say it this way, but like you could say, "Oh, you just use the LLM. You don't need to be good at writing for loops." Actually, wait, let me rephrase this. People have been saying, "Oh, before LLMs, you had to be good at writing for loops and all the tiny little details and you had to get them all right." And that was necessary to be a good programmer. But and now that there's LLMs, that's not true anymore. Now you don't have to be precise with all these things. You just need to get the big picture right. Well, guess what? That was also true before. You never had to be really all that good with for loops. Case in point, my shit keeps looping forever. Apparently, you just need a fuzzer to find those cases for you, and then you fix your sloppy code. So check this out. Why are you? Oh, right. It's because the argument is the output, not the file path. I should just make it the file path. But anyway, so we put this into faz.ziggy, or let's put it in repro.ziggy. That's where I was putting it before. Cat repro.ziggy. What's in there? Oh, there's tons of garbo. That's what there is. That's for sure. There's certainly a ton of commas. Uh, Actually, we should be able to see this also with ZigFNT proper, right? Let's see. No, we reached the end. 2360. Wait, are you saying that we were just slow? I think we were just slow. This is not an infinite loop. This is yeah, this is just reproing slow. So, okay, to be fair, we're looking at a file that has 23,000 has about 23,000 commas in a row. But are we doing some like stupid stuff when dealing with the commas? I don't think we are. Let me see where we generate missing following value. Maybe that is gonna give us an idea. So we make missing value when begin value hits a token that is not one that is the start of a value. And that is essentially the only place where we do this. But what happens when we do this? We add a missing value child. And then we go up, which makes us close whatever we were doing. So no, this also makes progress. I don't think that this stuff is inherently slow. I cannot remember if there is any real place we're doing any backtracking in the parser. We don't. We just don't. I think it just happened to be a opportunity for the parser to create something annoying in a compact way. Yeah, actually, you can see this whenever this number goes back to being small, you can see that essentially we're trying to run this process multiple times. Oh, you know what? Wait, actually, I was. Yeah, so here's what is happening. Okay, we are not running the initial just parse it once test. We are running the deserialize this input into any one of these types test. There's a bunch of types. Every time one of those fails, we run everything through the parser in order to produce good error messages. So we do that a few times. Okay. This all makes sense to me. This is fine. These are just happen to be slow because we're doing a lot of work. We could tell also the fuzzer that we could tell the fuzzer that this is the case. But yeah, indeed. Also, to be clear, this stuff is slow, but we are running it on a debug build. we're running it on Fuzz Repro, which is running in debug mode, not in release mode. So the fuzzer in any case is faster than this. You're just looking a lot of work happening in a debug build. Okay. I think I need to look into the LSP and try to unfuck that. That's one thing for sure. Then what is the next thing that we want to do? I think after that, what we want to do is I don't know. I am starting to really think that maybe these enums should be with an @ sign instead of a dot. Uh, or we use an @ sign for the unions. I don't know. Nah, this is fine. I think we need to figure out what's going on with the schema. Why is this causing an LSP error? LSP failed. This should not cause the LSP to fail. What the heck? Yeah, undeclared identifier without going insane. Unexpected message. Filter std out. Oh, it's because it's on the SDR. Wait, what if I do this? Int. Okay, now the formatter is happy, but the LSP fails. Okay, what's causing the LSP to fail? We're not seeing anything in here. Oh, oh no. This is Ziggy underscore schema. Extensions, yes. Parser actually should be with an underscore. I think we might have found the problem. Never mind, LSP failed. Why am I being so bad at... also, wait, don't we have some... the fuck is going on down here? Why am I getting a terminal? I'm getting a terminal down here. There's disgusting ZSH for some reason. But where's the log stuff? View log. Error in LSP. Let's start. LSP failed. We see LSP failed, but we don't see any logging from the LSP. Out of curiosity, what if I use Helix? Because I remember that Helix was configured on my machine. Oh, there's a Z directory? No, but there's nothing in there. So wait, this is working. Partially distributed dash. Yeah, but that is that is something. Yeah, technically that is wrong, but I do see syntax highlighting in here. So, uh, what am I editing? So the fact that that I see that makes me think that they should not be touched. Sorry, this is Ziggy schema. Wait a second. Why am I back in Ziggy? Unknown file type. Oh, I think we're starting to see what's going on. I changed the file name and that has caused a bunch of problems. Okay, so I did something that I should have not have done. Does this help? Yeah, now I have two Ziggy schemas. The other one is wrong, but this one is okay, I think. So now, I guess here's what I need to do. I need to make sure that we go into my definition when loading a file, not the built-in one. I'm gonna fuck up the file extensions. I'm gonna the one that Flow has. So I'm gonna just say that this is the only extension that it should concern itself with its own definition, so that we pull in mine. We still have we're still causing the LSP to fail. I don't know where this stupid fucking LSP is logging right now, so that's what we're gonna have to fix next. But at least we're starting to figure out what's going on. And look, in this editor where everything is configured correctly, it just works as it should. Yeah. So this LSP is like doing fine. It's just the flow config being out of whack. Alternatively, we could make the LSP more lenient and have the LSP accept also the dash, even if it's not an underscore. But I think I'm using a to enum thing. So yeah, I'm using string to enum. I'm using string to enum, and my languages are I don't even know where they're defined. Logic.language. Yeah, I just have these three guys. I guess we could do this. Hopefully, we're not relying on being told the language ID of anything else anywhere else. So that's one thing that we could do. And the reason there's this difference is because some things just do not accept the dash. No, there's something else going on here. There's definitely something else going on. Um, hmm. Yeah, I don't know what the fuck is going on with Flow, because with Helix everything works fine. So I think this is a Flow issue that I just don't know how to fix. And it's probably something silly just based on the fact that the data for Ziggy is compiled wrong in Flow. So I would say not a big deal. Let me check in Helix how we're doing with regards of everything. So we're gonna say that our the root of our document is foo, and struct foo contains apple, banana, and I don't know, mango. Mango is a bytes, and Zig is instead a dict of arrays of uh ints, of floats. As simple as that. So that's the repro Ziggy schema. I'm gonna open repro just Ziggy, which is full of garbage. Let's clean it up. Okay. There we go. I'm starting with a dictionary, and it's schema says expected who found a dictionary. So I make it a struct, and it says missing field Zig. Well, there's a few fields that are missing. Can I get? Oh, how do I get autocomplete? Oh fuck! I know how to get autocomplete in Flow. I don't know how to get autocomplete in Helix. Um, um, it's not autocompletion. I don't know how you change this. Come on, man. It is auto completion. It is auto completion, and somehow it's failing to provide this. Why? Uh, well, auto completion should be working. I don't know why I'm having trouble. So missing token equals yeah. So what was Zig false? Expected found bool. Okay. So expected a curlies. Banana was this. There you go. So the DSP is working. I don't know what's up with the auto completion. It does work. I'm fairly confident that it does work. I just don't know how to trigger this in this editor, I think. So yeah, we're doing fine. I can even do go to definition. I can do space K and go to definition. Oh, do we not oh, right. So what's happening is that if you edit the config file, those changes, oh no, they are being picked up. Never mind. I was pressing the wrong button. Okay, there we go. Banana, banana, banana. Probably want to put this on banana. Apple is, I don't know, expensive computers. There you go. So we have stuff. We have lots of stuff. Uh, I think that this might be it for me today. We have fuzzed. We have covered a lot more ground. We are now at a point where we are kind of running the fuzzer over not the totality of everything, but we are covering a lot of ground. We are getting, I think we are finally getting to the point where to get to the next stage of fuzzing, we really need to have a smith that guarantees that we make good tokens. Actually, we can do better than just make good tokens. We can make we can guarantee that we make like good elements. Yeah. So this is it. Thank you all for hanging out. It's been a pleasure as always, and I hope you had a good time. I hope you learned something, and I'll send you all to Toggle, who has been streaming. So you know what? I'll give him back his own raid. So go enjoy some Rust from the game dev, and I don't know. I'll see you next time. Bye all.